Good morning, all of you. Today we'll do one numerical on MCT. First of all, write down the question of the numerical. Okay. First of all, write down the question of the numerical. What is that? During pure orthogonal turning of a metal rod by a tool of the following geometry: inclination lambda, orthogonal rect 0, principal cutting edge 90. It is noted that the magnitude of the tangential component Pz, axial component Px, and of the cutting force are 600 Newton and 200 Newton, respectively. The value of chip reduction coefficient 1.732. Okay, chip reduction coefficient 1.32732. Using MCD merchant circle diagram, determine the magnitude of shear force and frictional force in above condition. Okay. This type of numerical or the mechanics of machining, numerical based on mechanics of machining, uh, we will do in two ways. First is graphical method, second one is analytical method. I have already told the all the formulas of all the formula or the expression of forces during machining through merchant circuit. So first of all, if we want to choose we will go for the direct formula to solve the numericals. It is okay. Another way is graphical method. So we will learn both of them. First of all, we will learn the graphical method. Okay, the graphical method. First of all, this is our standard merchant circle diagram. Okay. What is given? Given is lambda is given. Inclination angle is 0 degree. Orthogonal rake is also 0 degree. Principal cutting edge angle phi is 90 degree. Principal cutting edge angle is 90 degree. Px axial component, axial force is 200 Newton, and Pz is tangential component. Pz is tangential component. That means this is given 600 Newton. All of this are given. Now draw a 2D diagram. Okay. In 2D diagram, where this is rotate in this direction. In tool chip interface, this force is Px. This is axial force. Axial force perpendicular to the axial force is Py, that is radial force, and Pz is at this point it is perpendicular of both of them in z direction. Okay, now what is that? This force is Pxy. Pxy in our notation it is called Ft. That means thrust force. Thrust force. Okay. What is that value? This is principal cutting edge angle. This is auxiliary cutting edge. Okay. Principal cutting edge angle is given so that this is phi means this is phi. Okay. Now this is phi. Now what is Pxy? Pxy or Ft equals to Px by sin phi. Okay. Px value is given 200 by sin phi. Phi is also given 90. That means 200 Newton. Okay. Okay. Ft is given and P Z is given. Okay. Now another point is given, that is tan beta 0 equals to, we already know, cos of gamma 0 by xi minus sine of gamma 0. What you get? Xi is given 1.732. This is xi and this is 0. Then what is the value of beta? What is the value of beta? Beta is tan inverse of this. Okay. So beta equals to, what do we get? 30 degree. Beta equals to 30 degree. Okay. Okay. Now let's draw Martin circle diagram for this. This is in the left side of the board. This is our standard diagram. This is our standard diagram. Now gamma in this numerical, gamma is 0. Gamma is 0. Okay. This is our XYZ axis. This and this. Gamma is 0. So first of all, we taking one scale. We choose 200 Newton equals to 1 centimeter. Then Ft or Pxy equals to what we get 200 Newton. We convert all these force in terms of scale. Then 200 by 200 equals to 1 centimeter. This is the magnitude or this is the scale factor. Okay, or Pxy equals to 600 Newton. Our scale is 200 Newton. Then this is 3 centimeter. Okay, Pxy 3 centimeter. Now, first of all, we draw or we obtain some values in the through our formulas. Beta, one is beta, another one is ft. Okay, okay, another one is f. Let's see very carefully because gamma is 0, so that this force is converted into this line, and so that this force equals to this force because the angle between, let's draw it will happen automatically. First of all, draw beta angle. This is what we obtain from formula 30 degree. 30 degree. Okay, this is 30 degree.